What's up, math fans? Recently, I've been talking about linear relationships. If you're comparing two things and the relationship is growing quickly, you might consider that exponential or quadratic. But if you have something called a constant rate of change, it's called linear. And I first explained it by using a table, and I said if something happens after 1 hour, and then 2 hours, and then 3 hours, then we start to look for patterns, and we determined if it's growing consistently, constant rate of change, it's linear. So if something is linear, you're looking for a constant rate of change, also known as a rate or a slope, okay? So I'm going to keep talking about rate and slope, and I'm going to show you how to find the slope between 2 points on a line, or basically 2 points on a graph, 2 points on a table. Anywhere there's a pattern, there's going to be 2 points. All right? What are the 2 points? They represent things. They represent relationships. Here's a relationship: 2 hours, 7 minutes. 7 inches. So this could be about snowfall. It's wintertime. We'll talk about snowfall. So it's been snowing at a constant rate. All right? This time I'm not determining if it's linear or not linear. I'm telling you it's linear, and we're going to figure out what the rate is. So after 2 hours of snow, there's 7 inches on the ground. After 5 hours of snow, there's 16 inches on the ground. I'm telling you it's a constant rate. You just got to figure out what is that constant rate? What is that slope? So you can use whatever method you want. I'm going to show you a formula, but this formula comes basically from a graph. So I'm going to graph it just to give you an idea. And my independent axis is the x-axis, my dependent axis is the y-axis. That's always the case. So you got to figure out which one is independent. Usually 99.9% of the time, ours is independent, and then the snowfall depends on the hours. So this is my x, this is my y, that's my mini table with 2 values. Okay, so 2 hours, 7 inches. 2.7 is here. Let me actually lower the graph so you can see this. But my goal is you don't need the graph after you understand what I'm doing. But let me lower this thing so you can see it. And since I only have positive, I can really just focus on the first quadrant. So let me do 2.7. 2.7 is here. And if you have graph paper, this will be super easy. 5.16 is here, and if you get a straight edge and connect, this is the line. I'm way off. I cheated a little bit. This is the line that represents the relationship. So the longer time goes by, the more snow is on the ground, and you can use this to predict if it snows for 10 hours or 20 hours or whatever. Okay? So also understand, when you're looking at a line, there's more than just the 2 points. There's infinite amount of points. These are just the 2 obvious points. So my question is, what is the rate? What happened from here to here? So slope is defined as rise over run. How did you go from here to here? Or really, how did you go from any point to the next point? I'm using 2 obvious points. You can use any 2 points. Well, I started here, and I'm going here. I want to know how many inches versus how much time. I want to know how many inches versus how much time, or hours. Okay? Basically, when you're comparing 2 things, you're asking yourself, am I doing hours per inch or inches per hour? Per is the line. All right? You're doing inches per hour. So, how many inches? Well, it started down here at 7, and now it's up here at 16. I don't know. That's 16 minus 7. It started over here at 2 hours, and now we're over here at 5 hours. What's the difference? How much time passed by? I don't know, whatever 5 minus 2 is. Okay? So my difference, or my slope, or my rate is going to be, let's see here, this is 9 inches. It increased 9 inches over a span of 3 hours. 9 inches per 3 hours, and when I divide or reduce that, I get 3 inches per hour. This is my rate, also known as my slope. That's it. So how do you find slope of a line? Slope between 2 points, meaning if I connect those 2 points with a straight line, well, I calculate my rise and my run. That's it. I write that down quick because I'm going to erase it. So to summarize, if I want my slope, actually we use the letter M for slope, so I don't have to write the word slope anymore. It's my rise over my run. I'm comparing how much I went up by how much I went over. How did I find how much I went up? You count boxes, you can count how much you went up from down here to up here, right? Or you can just subtract. So that's known as the change in Y, or the new Y, Y2, minus the old Y, Y1, over the change in X. This means change, or delta. That's a Greek letter, in case you're in a fraternity or you actually speak Greek. Okay, so how did I find my change in X? How did I know how many I went over? You can count boxes, literally counting on the graph paper, or you can just subtract the new X, X2, the second X, minus the old X, X1, the first X. Alright? Rewind that so I can explain it again. What this means, how you find it. Alright? Counting boxes or just plain subtracting. Basically, how you find the distance from here to here, you subtract these numbers. Distance is subtraction. Remember that. Alright, so there's your formula. You can pretty much end the tape now and the show, but I'm going to do two more just for fun. I give you these big numbers on purpose because now I can't count boxes because I'm not going to graph that. I don't have 105 boxes. It's going to take me forever. So I'm actually rather just use the formula, no graph. So if I want the slope, I need to do y2 minus y1 over x2 minus x1. And I have no idea what that means. But I did learn that coordinates or relationships are always x comma y. So this is x, this is y. This is also x, this is also y. I'll call this my first x and my first y, which has to mean this is my second x and my second y. And now it's basic substitution. y2 is 105 minus 35. Basically, I'm trying to figure out how much money I earn per hour this time. This story would be about money in hours. After 3 hours, I have $35. After 10 hours, I have $105. How much do I earn per hour? Understand, when you make money, it's usually linear, unless you made some great genius investment. Alright, so how much money did I earn from here to here? I'm going to subtract. How much time went by? Well, that's between 3 and 10 hours. My x2 is 10, my x1 is 3, so that's going to be 10 minus 3. And let's see, 105 minus 35, is that 70? And 10 minus 3 is 7, which means that's 10. 70 divided by 7 is $10 per hour. There's my rate, also known as my slope. Rise 10 over 1, rise 10 over 1. You can graph this very easily. Don't need 105 boxes to show that. Last one, no need for a story this time, just showing you numbers. They could give you 2 points and say, what's the slope? Simple as that. So see if you can figure that one out on your own. A lot of people get scared, run to the calculator because they're scared of negative numbers, and that's fine. So first thing I'm going to do is label x1, y1, x2, y2, and then I'm going to do it. So again, you know your formula, write the formula first, and then plug in negative 11 minus negative 17. Notice there's a minus sign and a negative sign this time. This comes from the formula, this comes from the question. Over 5 minus 8. 5 minus 8. So it gets a little crazy here. When you're typing in the calculator, make sure you type minus and the negative. I don't have a calculator, so I'm going to try to do this in my head. If I see 2 minus signs in a row, that becomes a plus. So negative 11 plus 17 is actually 6. 5 minus 8 is negative 3. And that reduces to negative 2. My slope is negative 2. That's how you handle it in real life situations, on a graph, or just straight up numbers. Don't be scared of negative numbers. If you labeled it backwards and you said this is x1 and this is y1 and this is x2 and this is y2, everything would be backwards, which would make the top answer negative and the bottom answer positive, which would give you the same exact final answer. So don't be scared if you label it backwards. You're always good. Thanks for watching. See ya.